Hey, everybody. So I thought it might be necessary to look at the answer key for AP 2012-5 together because, man, right out of the gate, they try to shake your confidence. Looking at the circuit itself, the circuit is simple. All of you are very capable of solving for current, voltage, etc. at different points. But what do they do right out of the gate? Yeah, let's take a look. 4 light bulbs are connected in a circuit with a 24-volt battery as shown above. No mention of internal resistance, so we have to assume that the 24 volts is the terminal voltage. Now, it says, determine the average potential energy change of an electron as it moves from point Z to point X. I wish I had a record scratch sound effect because, we all know that current is the flow of positive charge. That's the convention in electricity. That's what we always use. Yet here, it's actually asking you to find the electron. Now, the electron's potential energy, as it goes from Z up to X, one must realize that our talk about positive flow going this way really is negative charges going that way. Now, with that said, let's just think about the potential energy of the electron. If everything is turned upside down, right, that electron is going to travel across that 20-volt difference. Is it going to lose potential energy or gain potential energy? It's obviously going to lose potential energy because it's going to convert that potential energy into light and heat. That's what light bulbs do. So before I do the math, I know that that electron is going to lose potential energy. So I know I should have a negative sign in my answer. Now, for one electron, we can say the energy, the change in energy, is going to be Q delta V. Now, delta V is just going to be the voltage final minus the voltage initial. It goes from 0 to 24 volts. So I do the 24 volts as my final voltage minus 0. So the change in voltage will be positive 24, but the charge, I plug in that negative sign. And I end up with the change in the electrical energy is negative 3.84 times 10 to the 18th joules. And that is for one electron. Now, is that a question that I like? Heck no. They're clearly trying to knock you off your game. However, if you can get through that one, you should be able to get the rest of these. Even if you can't get through that one, you can still do the rest of them if you stay on your game, because you actually don't need that part. You ready? Here we go. Let's keep going on the circuit. It says, calculate the equivalent resistance of the circuit. I feel like if you redraw that as a waterfall with 24 volts at the top and our 6 and 3 in parallel with each other, that's easy to find is 2 amps. 12 and 24 in parallel, it's going to give you 8. So the total resistance of the circuit is 10 amps. You all should have been able to get that. If you didn't, it's because you got frozen by up here. Got to move on. Move on. Next, calculate the magnitude of the current through point Y. Okay, so I need to find the current right here. To me, I know that that's going to be the current through the 3 ohm resistor. So I need to find the current through the 3 ohm resistor. Let's go back down here. Now, I know that in my circuit, I can easily find the total current by using the formula voltage total equals current total times resistance total. So 24 divided by 10, the total current is going to be 2.4 amps. Now that 2.4 amps is going to split. All right, some of it's going to go through the 6 ohm and some through the 3. Some of you already see the answer intuitively, but not all of us do. So a concrete way to go about it is that if you go to your waterfall where it's at 2 ohms and 8 ohms, all 2.4 amps has to go through the first set and then also through the second set. And since the first set of resistors have a resistance of 2 ohms, that's going to lead us to a voltage drop of 4.8 volts. Now, when I break my waterfall back out into the 6 and 3 ohm resistors, I end up with a 4.8 voltage drop. For the 3 ohm resistor, 4.8 divided by 3, I get 1.6 amps. It's just a reapplication of Ohm's law. Okay? Some of you see the ratio there. Good for you. Now, next question says, indicate on the diagram the direction of the current through point Y. Man, are they messing with you. Because current is the flow of positive charge, not electrons. So you would mark that as the current would be going this way. Yeah, that's just mean. Next, calculate the energy dissipated in the 12 ohm bulb in 5 seconds. Well, in the 12 ohm bulb, I realize that the voltage drop is going to be 19.2 volts. I could have solved that a couple different ways. Here I did it by using the current through the 8 ohm resistor, which is 12 and 24 together, is 19.2. So that means there's a 19.2 voltage drop across the 12 ohm resistor. So then, to find the change in energy is power times time, V squared over R times time. So if I do 19.2 squared over a resistance of 12, all times 5 seconds, I get an answer of just a moment. I got about 154 joules. Sound okay? Good. So in 5 seconds, it would be 154 joules. Now next, rank the bulbs in order of brightness. Oh, this is like a tipper, with 1 being the brightest. If any bulbs have the same brightness, give them the same ranking. Now, some people may think that the voltage drop would tell you the brightness. Others may think it's just the current. But really, it's the electrical power, the rate of change of energy, that would be the easiest to use. Now, we're all looking at incandescent bulbs, so I can say brightness is related to power. So I wrote out my 3 formulas for power. P equals IV, P equals I squared R, and P equals V squared over R. And any of these would work. It just depends on what information you have. When I looked at it personally, I knew the voltage drop across all the resistors, and I knew the resistance. That means less work for me if I utilize this formula here. So what I did was I plugged in for my 4 light bulbs, and I got these values. And here's the thing. I went to go punch it into my calculator, and I thought, wait a minute. I'm pretty sure I can do that in my head. 19.2 squared over 12, that's going to be the biggest number. And I just went in order. You could easily calculate it if you need to, but you don't have to, right? Like a tipper, you just get to that answer. I feel pretty good about that. So my answers were bulb A was 4th brightness, bulb B was 3, bulb C was the 1st, and bulb D was the 2nd brightest. All right. So that's a doozy. That's a 20-minute problem. And I'm sure I went over it in quite a bit less time than that. However, I'm sure it took you a while. But if you got that all right, you are in great shape. All right. Thanks for taking the time to look at it.